We are now going to take a look at EIGRP neighbor formation and maintenance. As a quick reminder, we remember that EIGRP supports automatic discovery of neighbors using periodic hellos. We can also configure manual discovery using neighbor statements, and also we can prevent the neighbors from forming. Now, to examine how the neighborship works and how it's formed in EIGRP, I think the best approach is to actually take a look at it from a practical perspective. So I'm not going to be talking about it, I'm going to be doing it, and I'm going to show you how the neighbors are formed. To do that effectively, I'm going to need a test network. And I'm going to start by building very simple test network. I'm going to start with just two devices. I'm going to start with routers R1 and R2 that are going to be directly connected. And this direct connection between them is going to be on the network 192.168.123.0/24. I will have .2 on this side, .1 on this side. And in both cases, this is simply going to be gigabit interface 1 on both sides. So what I want to do here is one more thing. I'm going to add loopback interfaces to my R1 and R2, just so I can have some routes down the road to exchange. And all of my loopback interfaces that I will be using in these examples are going to be in the following format. So it's going to be 192.168.0x/24, where x is simply a router number. So 2 in this case, or 1 in this case here. Next thing that I'm going to do here is I'm simply going to enable EIGRP in, let's say, AS100. So we are going to be configuring EIGRP AS100. And to make things a little bit more fun, I'm going to configure R1 using the old numbered method, and I'm going to configure my R2 using the new or named method of configuring EIGRP. So let's head to our terminal and configure this to begin with. So here I am on my R1, but before I start configuring anything, I need to make sure that my connection between R1 and R2 is operational. The best place to start verifying this is to run show IP route connected. With show IP route connected, what I'm looking for here is the connected route for the subnet that I will be using, 192.168.123.0, and I can see I do have it connected on gigabit interface 1. I can repeat the same command on R2, and I'm looking for pretty much the same output. Now I'm just going to be pinging between them. So ping 192.168.123.2, and what I'm looking for here are the responses. So I want to be able to ping between these two routers. So let's ping from R2 to R1, because the last thing that you want to do is when you start configuring your routing protocols and start verifying them or troubleshooting them, the last thing that you want to be dealing with is an underlying layer 2 problem. So I have my layer 2 pre-configured here. I want to focus just on EIGRP configuration. So let's go back to R1, and the first thing that I'm going to do here is I'm going to type router EIGRP 100. So I'm going to go into EIGRP mode. Now, depending on the version of the iOS that you are going to be using, a certain EIGRP feature called auto summarization that summarizes the advertised networks on classful network boundaries may be enabled or may be disabled. Starting with iOS 15, that is actually turned off, and I am using version of iOS here that is slightly newer than iOS 15. But nevertheless, it's a good idea that unless you actually want to use this feature, it's a good idea to turn it off. The next thing that I'm going to do is I'm going to configure the network statement for the network that I will be using to interconnect between R1 and R2. Now, I can press enter here because remember, the network statement in EIGRP can be either classful or classless. This doesn't affect how these routes will actually be advertised in EIGRP, just which interfaces are going to be enabled for EIGRP. Since 192.168 subnets are classful /24 subnets, I don't really need to enter wildcard bits, So I'm just going to be using network statement like this here. But I also want to advertise my loopback. And let's say that in a case of a loopback, I want to make sure that I'm advertising only a particular IP address associated with my own loopback. So in this case, I am going to be using the wildcard mask. So right now, what I do have is on R1, I do have EIGRP turned on and enabled. I have not done anything on R2 yet, but at this moment, my R1 is already sending hellos. Let's take a look at them. What I want to do now is I want to go to my Wireshark here, and I'm going to start capturing just EIGRP packets that I might be receiving. And I'm going to start capturing traffic that comes on interface between 1 and 2, routers 1 and 2. And here it is, here is my hello. So let's dig a little bit deeper into this packet. Now, the first thing that we can see here is that this packet was sent from the source IP address of an interface of our R1, and we can see that the destination is 224.00.10. This is exactly what we expected to see. But one thing further that I would like to show you is the protocol header. So this is the IP protocol that we are looking at, and we can see that EIGRP is using a specific protocol number, protocol 88. Let's take a look at what's in the actual hello packet. And as we can see here, the packets are still arriving. They are being sent every 5 seconds, but we are just focusing on one of them. Now, the important thing to see here is that this identifies opcode, identifies that we are dealing with the hello packet. There are multiple EIGRP packets, as we are going to see later on, but this identifies that we are dealing with the hello packet. Now, in many of these fields here, we don't really care what it says, but important information is the autonomous system number. The autonomous system number is carried in hello messages, and if the autonomous system number doesn't match on two sides, we are not going to have a successful neighborship formed. Now, furthermore, here in the parameters field, another couple of things are very important. The first thing that we are going to notice is that the K values, the constant modifiers for the metric calculation, are going to be communicated. And traditionally, only K values from 1 to 5 have been used. K6 is a relatively recent addition to the iOS and to the EIGRP. But with the K values here, we can see the default values of K1 and K3 set to 1 are being carried, and all other K values are set to 0. Again, I'm going to talk in greater detail about the K values a little bit later on. And last but not the least, what we are seeing here is that the hold down timer, the hold timer, is being communicated. So the neighbor is telling us how long we should wait before we declare him as dead. I'm going to talk about even this a little bit more later on when we start modifying these values and examining them. So now we can see that there is this hello packet that has been communicated. But obviously we don't have any neighbors formed because I have not done any communication, any configuration on R2 side. So let's head to R2 and configure R2. You of course remember that I said that I will be configuring R2 using the new configuration mode, the named configuration mode. So let's start doing that. So on R2, the first thing that I'm going to do is I'm going to enable router EIGRP, and let's call it Cisco, for example. So this now puts me in the named configuration mode. Then I'm going to go under the address family IPv4, and I'm going to specify that I will be using the autonomous system number 100. This is exactly what I want to do. The next thing that I'm going to do here is I'm simply going to say network 192.168.123.0, and let's in this case specify the wildcard mask, and I'm going to say network. And before I proceed actually to advertise the loopback, we can almost immediately see that our neighborship has already been formed. So we can see here that the numbered configuration and the named configuration that we had before can perfectly coexist fine. So they are not mutually exclusive. This is a local to the router, the configuration mode. It's not something that is communicated in the hello messages or anything. So we can see that our neighborship has been successfully formed. But let's advertise our loopback here. So I'm just going to say network 192.168.0.0 and actually 0.2, and I'm going to make sure that I'm advertising the correct loopbacks, or I should say that I am going to be enabling only this particular IP address, only the interface with this particular IP address for EIGRP. So at this point, we should have our neighbors formed. But before we take a look at the neighbors, let's head back to the Wireshark very quickly to see if we can see any differences between hello packets sent by R1 and R2. I should say that I expect to see zero differences here, but let's take a look. So here is the one of the hello packets that has been sent, or that is being sent by R2. What we can see here are the parameters that we are expecting to see, or that we have examined just before. So let's take a look at one of the packets that were sent by R2. So here it is. And if I quickly switch, so I'm going to switch now between two packets, so I'm going to switch to 1 and 2, we can see that nothing changes in the output below. So this is fairly good indicator that these packets are carrying pretty much the same information. Here, obviously, we are going to see the change in the source and destination MAC address, and we are going to see the change in the source IP address, but the contents of the hello packets are the same. So this is important thing. There are certain parameters that need to match before the neighbors can form. These parameters are key values, the autonomous system, and the authentication settings. We have not configured any authentication yet in this configuration. We see that our hello packets are the same. We see the log message above telling us that the neighborship has formed. So let's use now iOS to tell us a little bit more about this relationship. So I'm going to head back to R1 for no particular reason, and I'm going to run one of the very fundamental verification commands, show IP EIGRP interfaces. Now, show IP EIGRP interfaces is a very useful command. The first thing that it's going to tell me is all EIGRP processes that I might be running on this router are going to be identified with their own AS number. So if I have multiple EIGRP processes, I'm going to see this output pretty much repeated here for all the other processes. So this output here is going to be repeated. The next thing that is very important in this output is the list of interfaces that are enabled for this particular EIGRP process. The next important information, and this is fundamental, is this column here. Here I can see on which interface how many neighbors, how many peers I am seeing. So here on gigabit interface 1, we are seeing one peer, and that's exactly what we expected to see, because you remember, we have R1 connected to R2. So we are expecting to see on this interface on gigabit 1 on R1, we are expecting to see R2, and we are going to pretty much expect to see the same output of this command on R2. The rest of information here is really not that important at this stage of verification, but another output, another little more detailed output of show IP EIGRP interfaces might be something that you need to remember. So I'm going to say show IP EIGRP interfaces gigabit 1, or actually I should say show IP EIGRP interfaces detail gigabit 1. So with this output here, I'm going to get the summarized information that I have already seen. So this output I have already seen for this gigabit interface, but this output here gives me a lot more detail about how this interface is configured for EIGRP. Most importantly, it is going to tell me what is the hello interval that is configured on this interface, and it's going to tell me what is the hold down time configured on this particular interface. Now, keep in mind that this hold down time here is not the time that we have received from the neighbor. This is our own local setting. This is what we are going to be sending in our own hellos, and that the neighbors are going to be using when they're maintaining their relationship with us. And the rest of the output, as I say, is not so important at this stage, but the important output is this thing at the end here that says that authentication mode is not set. So in the case that you're troubleshooting relationship with EIGRP, these are the things that you need to look at. Do you have any peers? What is the setting of hello and the hold timer, and also what is the authentication mode that has been configured on the interface? Several times so far I mentioned the hold timer, and that that it's not locally significant, but it's actually communicated in hello messages, which is something that we have seen in the hello messages themselves. So let me elaborate on that a little bit. So when we have two neighbors that are directly connected, just like in the case of our R1 and R2, what we are going to have is locally configured hello time that may or may not be the same on two sides. Now, each of these routers is in these hello intervals, whatever they are going to be sending independently of each other, they're going to be sending hellos. But in these hellos here, they're going to include information after how long time of not hearing from that router should the other router declare it as unreachable. So let's say, for example, that R1 here was setting dead time or the hold time to 15 seconds. Now, this information will be communicated in each and every one of these hello messages, which means that R2 here is going to be using this information received in hello messages to determine whether R1 is alive or not alive on this segment. If R2 does not receive any hello messages from R1 in 15 seconds, R2 is going to declare this relationship as broken, as non-operational. But for example, at the same time, on the same link, we could have R2 here saying that, you know what, use the hold timer of 20 seconds. So this information will be included in every single hello message here, which means that R1 here is going to be using this information here to determine whether R2 is reachable or not. So in this case here, R2 may declare R1 as unreachable after 15 seconds of unreachability, of 15 minutes since receipt of the last hello message, but R1 may need to wait 5 more seconds after R2 has declared this neighborship as dead before it declares it as dead. So let's see this in action. Let's see how this thing may play out in the configuration. As an exercise, let's first change our hello and hold intervals on both R1 and R2. So let's, for example, set hello interval to be, say, 4 seconds, and let's say that our hold interval now is going to be 12 seconds. There's no particular reason why I have chosen these particular numbers, other than it's not the default, and they're low enough to be useful so that we can actually see some of this behavior. So let's first do it on R1. Now remember, R1 is configured using the traditional numbered EIGRP configuration mode. And we can see that configuration if we take a look at the router EIGRP process. If we want to modify the hello or the hold intervals for this router, we would have to do it on the interface itself. So I'm going to go to my interface gigabit 1, and I'm going to say IP hello interval, and here I have to specify the process number EIGRP 100, and I'm going to specify what is going to be the interval between my hellos. So my hello interval is going to be 4 seconds. Then I'm going to say IP hold time EIGRP 100, and I'm going to set this to be 12 seconds. So if I take a look at my interface, show interface gigabit 1, sorry, show interface detail gigabit 1, show IP EIGRP interface detail gigabit 1, here I can see what is my configured hello interval, and I can see what is my configured hold time. And I can see that my locally configured hold time there is displayed. On the other hand, if I go to R2 and if I do show IP EIGRP neighbors, and if I do show IP EIGRP neighbor detail, if I take a look at any of these outputs, I'm not going to be able to see what is R1 telling me. The only way that I can figure out what is the hello interval is if I repeat this command multiple times and kind of try to guess based on the current hold value here. And I can see here that the maximum value that I have observed was something around 10 seconds, or if I'm really quick, it's going to be 11 seconds. So this tells me that my hold interval configured on the neighbor here is either 11 seconds or 12 seconds. It's not much above that. So there is no really show command that will show me what is the neighbor's configured hold interval. This is something that I have to deduce, that I have to actually guess. Now, let's do the same thing on R2. Now, remember, R2 is configured using more modern named configuration mode, and here it's configured differently. So what I'm going to do here is I'm going to go into router EIGRP Cisco. So I'm going into my named configuration. I'm going to say address family, IPv4, and autonomous system 100. So this is what I'm configuring, and I'm going to say AF interface gigabit 1. And here I'm going to say hello interval 4 seconds, and I'm going to say hold time 12 seconds. Now remember, with this new configuration mode with the AF interface, I could have easily said default here, and this would apply to all the interfaces, but I'm just focusing myself on a single interface right now. So if I do show IP EIGRP interface detail gigabit 1, I can see now that my configuration has been applied. I can see that the hello interval is 4 seconds and the hold time is actually 12 seconds. Now, let's break this a little bit. I'm now going to do something that you should never try in real life, and that, quite frankly, EIGRP shouldn't allow me to do. What I'm going to do next is I'm going to configure the hold interval, the hold time, to be actually lower than the hello time on my R1. So I'm going to go to R1 here, and I'm already in the interface configuration mode. And I already know that my hold time has been configured as 12 seconds, and I know that my hello interval has been configured as 4 seconds. So what I'm going to do now is I'm going to configure my hello interval to be 24 seconds, so 2 times the hold time. So if I take a look at this output, take a look. This is, quite frankly, nonsense. This is a broken configuration. But what I'm trying to do now is to cause exactly this. I want to show you how this is going to play out. So what is now going to be happening is the neighbors are obviously going to disengage. We are going to have a problem, and then the neighbors are going to re-establish, because there is nothing wrong with sending hello messages except that they are arriving too slowly. But too slowly for whom? Who is making this decision that this needs to break? Well, the key point or the cue there is in this log message. We can see here peer termination received. It is R2 who is actually making this decision. And if we take a look at R2, we can see here information that the holding time has expired. Why did the hold time expire? Well, let's see what is happening. What is happening here is that R1 is sending hello, and it is saying in this hello, if you don't hear from me in the next 12 seconds, declare me as dead. And then the next hello is due 24 seconds after this first hello here has been sent, about halfway through there, what's going to happen? R2 is going to say, hey, look, 12 seconds have elapsed, but I have not heard from you, so I'm going to send you the termination. Your whole timer has expired. And R1 now says, oh, okay, so we need to terminate our relationship, so the relationship terminates here. But you know what? I'm going to send you another hello saying, hi, I'm here. And the neighborship reestablishes itself, and this repeats forever and ever. And we can see that it is repeating forever and ever because we have very, very unstable EIGRP right now. So let's fix it. So what I'm going to do now, I'm just going to return my hello interval back to 4 seconds, which is going to improve things somewhat. I would now like to expand our network just a little bit. So remember, we have at this moment, we have R1 and R2. What I would like to add is R3 on the exact same network segment that R1 and R2 are already connected. So what I'm going to do now is I'm going to configure R3 here, and it's going to have IP address .3, and it's also going to be gigabit interface 1. So this is gigabit 1, this is gigabit 1, and remember the IP addressing scheme is 192.168.123.0/24.1 here, .2 here, and .3 on R3. So what I want to do now is I want to add R3 to this mix, and I'm going to also be using named configuration there because I tend to like this new named configuration. I'm going to be using the named configuration here. I'm going to add R3, and I'm going to modify all the timers just as they are right now in our network on R1 and R2. Just like before I do anything, I'm going to make sure that R3 can actually communicate with any other devices. So I'm going to say, well, let's first do show IP route connected. I'm seeing here that I have 123 network configured, so I'm going to say ping 192.168.123.1. There's going to be ARP wait, and let's ping 2. We are waiting for ARP, and there we have the response. So let's configure our EIGRP. So I'm going to say router EIGRP Cisco, address family IPv4 unicast, autonomous system 100. I'm going to say here now AF interface default. So what I want to do here for all the interfaces, I want to declare them as passive. So I'm declaring all the interfaces as passive by default. So I don't want to send hellos on any interfaces unless I explicitly enable them. Then the next thing I'm going to say here is I'm going to say that my hello interval for all the interfaces is 4 seconds and that my hold time is 12 seconds for all the interfaces. Now I want my AF interface gigabit 1 to be not passive, so I'm going to do no passive interface under that configuration mode, and then I'm going to say network 192.168.123.0, and I'm going to enable this on my loopback as well. So now I can see already that I do have 2 neighbors that have formed the relationship. I already have that log message. But before we proceed with this example with this third router that I have added, let's see how this configuration looks. So I'm just going to say show run section router EIGRP, and what I'm seeing here is what I just configured. I can see that for all the interfaces by default, all the interfaces in this particular address family, I can see that my hello timer has been configured, the hold time has been configured, and that they are all passive. But this more specific definition here for gigabit 1 actually takes precedence, so no passive interface takes precedence. But what about hello interval and the hold down timer? What happens in this case? Since I have configured this, will this interface gigabit 1 be using the configuration from the default, or would this interface be using the default predefined configurations? Let's find out. I'm going to say show IP EIGRP interface detail gigabit 1, and I can see actually that, as I expected, the information from the AF interface default has been taken over by our more specific interface definition. So I can see here that the hello interval is actually 4 seconds and the hold down timer or the hold timer is 12 seconds. As a last example, I want to add one more device to my network. And this is going to be R4. And R4 will be connected directly to R1. And in this case, I will be using gigabit interfaces 2 for this network. And the network that I will be using here will be 192.168.14.0/24. And I want .1 here and .4 on this side. But what I want to do in this particular configuration, I don't want to send my multicast discovery packets. What I want to do here is I want to send unicast hellos. So let's head to our configuration and configure this. Now, as in previous examples, R4 here will be using the named configuration mode, and R1, remember, is using the traditional numbered configuration mode for EIGRP. So I will show you how this is configured in both cases. Just as before I start doing any configuration on R1 or R4, I'm going to make sure that I actually do have an operational connectivity between them. So on R1, I'm going to say show IP route connected, and what I'm looking for here is that I actually do have the connected route in my routing table, and I seem to have it. And on R4, show IP route connected, I can see my 192.168.14.0/24 in the routing table. So let's try to ping across, and from R4 I can ping R1, and let's try to ping from R1 to R4, and I seem to have the connectivity there. Now, before I proceed and configure EIGRP here to send only unicast hellos between these two neighbors, I'm going to head over to my Wireshark, and I'm going to start capturing here on my Ethernet 2 interface, and I'm interested only in getting EIGRP packets. So I want to capture these hellos, so I want to see how these packets look like, and I want to confirm that I am indeed sending only unicast hellos. So I'm going to start with R1, and remember, R1 is the one that is configured using the traditional configuration mode. So I'm going to go here and say router EIGRP 100, and I'm going to say neighbor 192.168.14.4. Now, if I press enter here, it's going to give me an information that this is an incomplete command. Why is it an incomplete command? Because I need to tell it on which interface am I configuring this neighbor. And in my case, this is going to be gigabit 2. Now, did this help? Am I getting any hello messages here? I don't seem to be getting anything here. I'm not getting anything because I still need to make this interface operational in EIGRP. So it's not enough to just say, okay, I'm going to have that particular neighbor active and I'm going to be sending unicast hellos to that neighbor, but I also need to use the network statement. So I'm going to say network 192.168.14.0. And actually, let's do it this way. So I want to activate only this one IP address here. So right now, if I go back to my Wireshark, I can see that my hellos are already being sent. And I can see here, based on the destination IP address, which is 192.168.14.4, I can see that they are indeed unicast. I can confirm that even if I take a look here at my destination MAC address. So going back to R4, I want to configure R4 for pretty much the same thing, but I want to configure it using the new named configuration mode. So I'm going to repeat what I have been doing all day long. So router EIGRP, going to say name Cisco, address family, IPv4, unicast, autonomous system 100, and here I'm going to say, for example, neighbor 192.168.14.1 gigabit 2. I'm going to say network 192.168.14.0, 255, like so, and I want to activate my loopback as well. And I can already see that I have new adjacency up and running. So let's head back to our Wireshark here, and let's see what kind of hellos are being sent. I'm getting a lot of traffic here. So what I'm going to say here is I want to specify the particular source IP address. So just the hello sent by R4 in this case. And I can see that even they are actually sent. Let me expand this a little bit. So we can see here that even they are sent as unicast. We can see that the source is 192.168.14.4, and we can see that the destination is the unicast one. So we can see that the configuration in the named and the numbered configuration mode for EIGRP, for static neighbors, for configuring unicast hellos between our neighbors is pretty much the same. While we are at it, while we are configuring all these adjacencies, let's do some authentication as well. And to do authentication, I'm going to use the simplest setup that I have. So I'm going to configure it between R1 and R4. And the authentication requirements are going to be that I'm going to be using perpetual key. And let's say that the password is going to be Cisco. And I want to use key identifier number 1. And I will simply configure R1 and R4 to use this authentication method. So let's go ahead and do it. So I'm going to start with R1. And remember, we are starting by defining keychain. So I can call it whatever I want to call it. So let's call it my chain. I'm going to define key number 1. I'm going to say key string Cisco here. So if I do show keychain, I can see here that the key number 1 with text Cisco as the key string. So here text information is actually what I entered as my key string. And I can see that accept lifetime and send lifetime are always valid. And it also tells me here in the output that these keys are valid right now. So I have defined the key now. Let's go ahead and configure this on an interface. So I have to go to the interface facing my R4, which is gigabit 2. And here I'm going to say IP authentication mode EIGRP 100 MD5. So I'm going to enable the authentication MD5 here, and I can see that my neighbor immediately went down because it is not responding to the authentication. But here I'm going to say IP authentication keychain, and I'm going to specify the name. Oh, actually I have to say EIGRP 100, and here I'm going to specify the name of my keychain, which is my chain. So if I do take a look at the configuration of my gigabit 2, I can see that my authentication mode and my keychain have been configured. Now, let's do same thing on R4. So I'm going to say keychain, and let's call it somehow else here. Let's call it EIGRP chain. Here, I'm going to define key number 1, key string 0 Cisco. So here I'm explicitly telling it that whatever follows is going to be unencrypted. But you know what? I actually don't like having unencrypted passwords. So I'm going to enable password encryption. So if I do show run section keychain, what I'm going to be seeing now is type 7 encrypted password here. But if I do show keychain, what I'm going to see here is decoded key. So even though this is here showing me the encrypted password, if I do show keychain command, I'm going to see unencrypted password shown. It's a very, very useful thing. Now it shows you how much security you have with type 7 passwords, but it is what it is. And here I can again see what is the accept lifetime and the send lifetime of this particular key, and I can see that this key is actually valid right now. So let's go ahead and configure our authentication. So I'm going to go to router EIGRP Cisco, address family, IPv4 unicast autonomous system 100, and you know what? I want to use this keychain on all of my interfaces. So here I'm going to say AF interface default, and I'm going to say authentication mode, MD5, authentication, keychain, and I'm going to use whatever name of keychain that was. So EIGRP keychain. So I have it now configured it, and as I can see, my neighborship immediately came up. If I take a look at my EIGRP configuration here, this is how EIGRP authentication configuration looks for the named configuration. If you ask me, this is much more scalable than what we had before Cisco introduced named configurations.